Hi and welcome. My name is Thomas, and in this episode we'll be looking at the Splunk challenge. Now this is a re-recording because I missed a few steps in the previous recording. So I already solved this in my badge, so Splunk is already marked as done. But since you can verify the answer in the Splunk instance, we can actually do this again. So it shouldn't be a problem. One of the things that we need to do first, that I'd like to do with this episode though, is that while there's no real associated hint for this particular challenge, there's no extra information that's provided by any of the elves. Tangle's Keypad challenge does reference the professor for the Splunk challenge, so I'm gonna use this one in this episode as well. So the thing that we have as information from Tangle is the code that he's looking for consists of 4 digits. One of the digits is repeated once. The value is a prime number, and you can see which keys were used. So let's open up the keypad. So you can see which ones were used. And this is 1, 3, and 7 because those are a little bit darker. One's going to be repeated. One digit is going to be repeated once. So either it's going to be 1, 1, it's going to be 3, 3, or it's going to be 7, 7. Since we have 3 numbers and one's repeated once, it's going to be 4 in total, and the number consisting of 4 digits is going to have to be a prime number. Now you could obviously try and find that manually, but that's going to probably take you quite a while. The way that I've solved this is I've created a script for this, which basically contains a function that verifies if a number is a prime number, and then goes over each of these 3 lists. Now the 3 lists consist of the possible options of those digits. So for the first list we have 1 duplicated and then 3 and 7. The second list has 1 and then 3 2 times and then 7, and then the final list has 2 times 7 and then 1 and 3 again. And the idea is basically that we're going to be iterating over each of these lists, finding all the possible combinations of these digits, verify if that particular number is a prime number, and if it is, add it to a list or print it to the screen rather, so we can have it ready to try. So let's run that code and see what we get. So we have 5 possible options, and to kind of save some time, it's actually the last one. It's 7331, but 5 options is definitely a lot more manageable to do manually than having to try every possible option, obviously. So 7331, let's enter that. 7331, enter, and it's valid. Perfect. And that would normally, if this hadn't been a re-recording, this would have opened the door, and we would have been able to then enter the dorm. Anyway, let's hop on over to the lab. And while we're going over there, this is actually the first time I record these kinds of things, so I'm not intending to do a lot of editing. These are just mainly the main purpose of these is just to add to my write-up for the KringleCon challenge. There we go. So heading over to the lab. There we go. And we've already been there, obviously, for the holiday Christmas cheer laser hint. Now we're talking to Professor Bannons. Okay, obviously I'm not supposed to click him again because I already did the challenge previously, but the idea is basically that his machine was hacked, right? He's got a message from one of the elves in the SOC called Kent. Kent notified him that his machine was being used for malicious activity, and that's also what we obviously gathered from the previous objectives. If we go back real quick, is we know what account was compromised, then we know how they compromised that attack by using which tool to dump those hashes, and then we found the compromised system. Well, now we're looking at that compromised system in this case. So hopping over to that Splunk instance, the basic idea is that you're dropped into the SOC universe. You need to talk to these elves, you need to talk to Alice, to Kent. They're going to give you hints. And to kind of get you started with using Splunk, there's a whole bunch of training questions where Alice also helps you by suggesting types of queries to run, the types of fields to use, things to look at, to kind of get you acquainted with how Splunk works. Now, First questions, I'm going to go through these training questions as well, just for completeness sake. So first question is, what is the short name of Professor Bannis's computer? You could search for that because you know the IP address, but it's also mentioned in the LFU-SOC chat history, which is Sweetums. So that's basically an easy one. Sweetums, we can add that, and that is correct. Perfect. Now let me open up the Splunk UI. There we go. If we want to search for this instead of just using the chat history, we could also use, knowing that this is Professor Bannis's system, we could use this query, and we're basically looking for this particular username, and then outputting it as a table which contains the time, the user, and the computer name. So searching for this, there we go. We would have sweetums.lfu.org. Another option would be to just keep it simple and search for the username as a string, not specifying any fields. There we go. And then you would have a field here to the left, which is computer name, which would give you the exact same information. So that's how you would answer question 1. Now, question 2. What is the name of the sensitive file that was likely accessed and copied by the attacker? Please provide a fully qualified location of the file. Now, the tip that Alice gives is similar to the first question. Just search for a string, and the string that we can search for is Santa. And the reason why is because Santa is the most likely candidate of sending around or being involved in sensitive documents. So, searching for Santa. And the first result is basically where we have the following entry, which is a document named Naughty and Nice 2019 draft.txt and a message to Carl. And that's what we need. It's also interesting, actually, now that I scroll down, there's some encoded PowerShell here. So maybe I'll just go quickly see what that is about. So let's echo that out and let's base64 decode this. Ooh, that doesn't look good. Download data. Looks like pretty obfuscated code as well. Definitely some bad things happening here, so we'll probably have to look into this. But for now, let's go and look at, or use this file name and copy that out. I think we need a full path, so I'm gonna grab it just to be sure. If I can manage. There we go. That's the path. That's the file name. Actually, we had to specify the full path, so good that I copied that. What is the fully qualified domain name, FQDN, of the command and control server? Okay, so let's see. Alice actually hints at using a particular sysmon event ID to find that, and one of the resources that I've used extensively for this challenge and in my day-to-day job as well is this particular encyclopedia, which talks about all the different Windows events types. One of them is sysmon event ID 3, which is for network connections. And so if we search for those and specify the sysmon log in Splunk, we should be able to find that kind of information. So the query that we paste in here is going, oops, need to have the full, yeah, there we go. So source type is going to be sysmon operational. We're going to be looking for PowerShell as a string, just generic search, and we're going to only search for event code 3 or network events. Search for that and see what comes up. Okay, so we do have network events related to PowerShell, that's fine, but what we need to find is what's the fully qualified domain name of the command and control server. So that's going to be the destination. So let's use the interesting fields over here to the left and look at destination host name or dest_host. They're both going to give us the information that we need, which is going to be that IP address, which we already saw in Rita in previous episodes. And now we have the fully qualified domain name, which is that IP address.vulture.com. So adding that in. Okay, that seems to be correct. Now, what document is involved with launching the malicious PowerShell code? We already saw that PowerShell code, right? We kind of decoded it here. So we know it's bad. Actually, what I did, if I go to challenges, and then the challenge for Splunk. I've already have it here somewhere. There we go, payload PS1. I cleaned it up just a little bit to kind of make it a little bit easier to read, although it's probably not that easy, I guess. So the thing that we see here is that there's a new web client object that gets created. Proxy settings get configured, headers get set, that's all fine. It grabs the bytes for this particular string, so that looks like an encryption key, most likely. And what it does is it grabs this file from this IP address. We already know that malicious IP address. It has a particular header. It downloads that data, and then it decrypts that data and executes it using IEX, which is invoke expression in PowerShell, which basically means run these commands. So that's how that malicious PowerShell gets executed. The problem is now, obviously, we need to figure out how that PowerShell got executed, right? What triggered that PowerShell to do that bad activity, to launch that bad activity. So to do that, we can use sysmon logs again. So what we're going to be trying to do, let's see if I can find what I need to find. We're going to be looking first, oops, I need to go here, Splunk, there we go. First, we need to look at the PowerShell logs, right? And I want to look at all this PowerShell activity that I can find. So that's why I'm going to add reverse to this query. So source type is going to be the PowerShell logs, and then I'm going to reverse that information so it shows me the oldest one first. Wait for that. There we go. So that's the first entry here. Now, what I'm going to do with this is I'm going to click on this first time, and I'm going to do ±5 seconds and apply that time frame. There we go. So what I've done now is I've basically limited the results to anything PowerShell still at this point, any PowerShell activity within 5 seconds of that initial event. Now, I'm not interested in just PowerShell, right? I want to know what spawned the PowerShell. So what I want to do next is I want to go and look for anything that basically happened within that time frame. So I'm going to remove both of these and run that again. And what I can do now is I can go over to process GeoID and process ID fields and look at all the different process IDs that might have happened there. You can either look for sysmon event ID 1. Let's see, sysmon event ID 1. There we go. Which is process creation. See if I can go to the encyclopedia itself. Windows, yeah, okay. Or I could look for event ID in the Windows logs for 4688. Let's see if I can find that here. Which is a new process has been created. So in this case, I'll be looking at those process ID first to kind of see. There's only 2, so it's probably good to grab those. So we have process ID 6268 and process ID 5864. So those 2 are kind of interesting at this point, right? And now I'm going to start looking through my Windows event logs for that code 4688, which is starting a process. The problem is that instead of actual process ID values in integer format, it's actually using it in hex. So we need to translate these to hex first in our query. So our query would be looking like this, if I can copy it over. So now that we have those 2 process IDs, we're back to the full time range. I'm gonna set that to all time, because what I'm looking for now that I've found those 2 interesting process IDs, I want to expand that time frame again to make sure that since we're looking at parent processes as well, that we have a time frame that's large enough to include those events as well. So translated those 2 process IDs to their hex equivalent, which is this. Search for them using process ID field. We're looking for event code 4688, which is process create event, and then we're looking for that in the Windows event logs. So as we run that, there's 2 entries that we run. One is going to be for PowerShell, one is going to be for Word. The one for PowerShell we obviously already know about because that is the actual bad activity, right? That's the actual execution of the PowerShell with those base64 encoded instructions, which downloads from that malicious IP address and then executes it using the invoke expressions command or parameter. The next one, though, is what we're looking for, because that is the Word process that spawned that particular PowerShell process. And if we look at the process command line, we can see that Word started, and it started by opening a specific document. So it looks like we're dealing with a phishing attempt, right? Someone sends a document to someone else, they open that particular attachment in their email client, and then in some way they're what's the word I'm looking for here? They're forced or they're made to execute that malicious code, that PowerShell in this case. Anyway, what we're looking for is this file name, so I'm going to copy that out. That's going to be the answer to our question here. What document is involved? It's just the file name. So file name, and that's done. Okay, next up. How many unique email addresses were used to send holiday cheer essays to Professor Banas? Please provide the numeric value. Okay, so there's a different log type that we can query for this. I'm not sure how to pronounce it. It's either stock or storeq, but this is the query that we're going to be using for this. So all of these email addresses, or all of these emails rather, are being collected by Splunk. All the metadata is going to be available for searching in Splunk itself. All the file artifacts that are involved in these emails, those are going to be stored in the file archive. So if we open that up, that's an Amazon instance. You're basically going to be able to navigate through this and find particular file related artifacts stored there. So we're going to have we'll need to combine both searches in Splunk and then download those from the file archive if we want to get to those files. Now for the query that we're trying to, the question that we're trying to solve here, the query is going to be, well, look through that log, right? And look for any emails where the subject equals holiday cheer assignment submission, which is what we're looking for here. We're basically looking for elves that sent their holiday cheer assignment over to Professor Banas. Most likely one of those elves didn't send an actual assignment, but was trying to do a phishing attempt on the professor. And then we're going to be using those results to count them by the how many times we had that particular subject. So let's run that. And what you'll see is there's going to be a duplicate entry because it's case insensitive. So we're going to see it for the normal case version of the subject line and also the lowercase version. But in any way, we have 21 results, not 42, but 21. So let's add that in there. Done. Okay, next. What was the password for the zip archive? Okay, cool. So obviously our attacker sent that email. It was password encrypted. They're going to have to give the password in that email to the professor as well to make him decrypt that file and execute it, obviously, and open it in Word. So what I'm going to do for that is I'm going to look for the string password inside of the body of the email, and then I'm going to format that as a table where we'll see the from address and the body as well. So execute that. And we have two entries, two results basically. One is from Professor Banas and other is going to be from Bradley Buttercups. We're not really interested in the response from Professor Banas at this point, but Bradley Buttercups does speak about that password for the attached zip file. So let's copy out that password and put that in as an answer. And that's done as well. Okay, and the last question we actually already answered with that same query. What email address did the suspicious file come from? Well, it was from Bradley.buttercups and here's one of the things that you'll typically see with phishing attempts. They're trying to make it look like the actual domain, but it's not that actual domain, right? It's instead of elfu, they're basically using a capital I to kind of make it look the same. But it's definitely not the same. So the email address is going to be bradleybuttercups at elfu.org. There we go. And that's all those questions. So that's all the training questions. Now the main challenge question, what was the message for Kent that the adversary embedded in this attack? Before answering that question, I'm going to look at that email message from Bradley and look at how it's formatted basically. So there we go. So we're going to be looking for through those stock logs for anything that comes from that particular email address. That should give us that one email from Bradley. Let me do the formatting, see if I can do raw. Nope. Is list what I want to have? Yes, list is what I have. Okay, perfect. So what you'll see here is that in the results, so this is JSON basically, right? And in the results field, you'll have different results where it actually tracks all the different files that are part of that email. It's also going to be stock basically also extracts the zip files, for example, or extracts artifacts, etc. From files, and they're going to be stored in a specific location on the file archive server. And the path you'll find in this particular location, whereas the I think it's file name should be here under payload meta dispatch, extra data file name. So both of these portions, both of these pieces of information could help us find the original file on the file archive server and look at that in more detail. Now, one of the hints that Alice gives us to search for this and to answer this is a query that looks like this. So obviously we're going to try and find that, or we're grabbing that email from Bradley. Then we're going to be evaluating or parsing basically, quote unquote, the results entry, which is this. In that results entry, we're going to expand what's in there. So each of those entries here, right? Each of these entries that align with one particular file artifact, we're going to loop over those. And for each of them, we're going to evaluate or search for the path and the file name, which is basically stored in archiver's file dir path or payload meta extra data file name, as I mentioned earlier. So it's going to be either in archiver's file dir path, archiver's file dir path, or it's going to be in payload meta extra data file name in payload meta extra data. There we go, and file name. So we're grabbing both of those pieces of information, and only if the path value is not empty, we're going to show both the file name and the path on the file archive server in a table format. So search for that, and that should give us all the file artifacts that were grabbed as part of that email. Now the ones that jump out are obviously going to be that original zip file and the associated doc file here. One thing we could do is we could download that doc file, which is C6E17. Just for completeness sake, I'm gonna go there. Yep, that's it. And you can download that if you want to. There we go. I already downloaded it here. C6, so I'm gonna cat that out. What is it? C6E17. There we go. Now, they've replaced, for the challenge, or sorry, for the event, they replaced the actual contents, just to not spread around malicious files. But the actual contents of the file does provide a hint, namely that the core.xml file that was a component of the original macro-enabled Word document is still in the file archive. And that's the one we should be looking at. So, going back to our results, we'll see that core.xml file, which is stored on the file archive in this particular path. The file name basically starts with ff1e. I also downloaded that one already. So if I cat the results or cat the contents of that file, what you'll see is in the description, it basically has a message to Kent, which says, "Kent, you are so unfair, and we were going to make you the king of the winter carnival." So, grabbing that, and going back to Splunk and putting that in as the answer. That is the answer to that particular challenge. Now, What we still need to do, obviously, if this wasn't a re-recording, I would have to add it as an objective, answer to my objective, but I already did that, so it's marked as completed. And that's the end of this particular episode. In the next episode, we're going to be meeting some new elves and some mysterious NPCs as well, as we try to get access to the steam tunnels. Hope you enjoyed this episode. Hope to see you in the next one. Have a great day. Bye-bye.